Hello everyone, welcome back to my channel. In this video, we'll be solving another problem from the 27th Philippine Math Olympiad qualifying stage. This is part 3, problem number 7. Let p of x be a polynomial of degree 3 satisfying p of 2 equals 6, p of 6 equals 2, and p of 1 equals p of 8. There exist positive integers a different from 2 and 6 and b such that p of a equals b for any p satisfying these conditions. What is the value of a plus b? Let's begin by creating a representation of the polynomial p of x by using the condition that or the conditions that p of 2 equals 6 and p of 6 equals 2. So what information can we get from these two conditions? The condition that p of 2 equals 6 means that if we divide the polynomial by x minus 2, the remainder is 6. The second condition means that if we divide the polynomial by x minus 6, the remainder is 2. And since the polynomial is of degree 3, we can actually represent it with this form. Okay, so since we don't know the leading coefficient of the polynomial, let us represent that leading coefficient by c. So the polynomial can be represented by p of x equals c times the product of these three binomials. Okay, so x minus 2 comes from the first condition, x minus 6 comes from the second condition. Now, since again the polynomial is of degree 3, there must be another binomial here to satisfy that condition. So let us represent that binomial by x minus s. Now, why do we have 8 minus x as the remainder? And is this the correct representation or form of the remainder? We can actually verify this one by plugging in x equals 2. So if you plug in x equals 2, you get 6 here, which verifies this condition. Now, if we also substitute or plug in x equals 6, we actually get here 8 minus 6, which is equal to 2. And again, this verifies p of 6 is equal to 2. Okay, so in this representation, we can also observe that there are two unknown quantities and we want to get rid of this quantity so that we can simplify the left hand side of the equation. So how do we do this? We can actually use also this one, this condition, p of 1 equals p of 8. So let's plug in x equals 1 first. So if we plug in x equals 1, we get p of 1 equals 5c minus 5cs plus 7. If we plug in x equals 8, we have p of 8 equals 96c minus 12cs. And since p of 1 is equal to p of 8, let us equate these two expressions to get 5c minus 5cs plus 7 equals 96c minus 12cs. Now if we combine like terms, we will get 91c minus 7cs equals 7. 91 is actually divisible by 7, so let's divide both sides of this equation by 7. So we will have the result c times 13 minus s is equal to 1. Now if we go back to our representation of p of x, there is this part c times x minus s. So this one somewhat resembles the left hand side of the equation c times 13 minus s equals 1, except that there is no x here. Instead, we have the number 13. So if we actually substitute x equals 13 in our polynomial, we actually derive c times 13 minus s in the right hand side of this polynomial. Okay, so if we do that, we will have this result. Okay, so p of 13 is equal to this long chain of expression, and if we simplify the right hand side, we get c times 11 times 7 times 13 minus s minus 5. Let's simplify this further and rearrange the terms. So after doing that, c times 13 minus s comes out, right? And we know already the value of this, and it's only 1, right? So if you replace this one by 1, we get P of 13 equals 77 times 1 minus 5. Okay, simplifying this further, we finally get P of 13 equals 72. Okay, so if you look at the input, that's actually the value of x, right? That's a in the problem, which is different from 2 and 6. And the b that the problem is referring to is actually 72. So our final answer here is just the sum of these two numbers, a plus b. So the answer is 85. If you find this video helpful, please like, share, and subscribe. Thanks for watching.